r to the negative first power. Continuing to simplify, again, if we have negative exponents, we can rewrite that using a fraction. Negative 240 would stay the same since it does not have a negative exponent, and also m to the third power would stay the same since it does not have a negative exponent. R to the negative 1 has a negative exponent. We can rewrite that in the denominator using a positive 1 exponent. So our final answer would be negative 240 m to the third divided by r to the first power. Title of the last section today is Scientific Notation. In this section, we'll simplify questions using scientific notation, which is a notation to represent large or small numbers. First question, in parentheses, is 2 times 10 to the third power times a second parentheses 3 times 10 to the second power. Scientific notation. This question has two problems or two numbers, each in scientific notation. Scientific notation, you have a number times 10 to some exponent. The number, though, has to be some number between 1 and 10. It can only be a single digit number. It could have decimals afterwards, but it can only be a single digit number and can be no larger than 10. Times 10 to some exponent. The exponent could be positive or negative. In this case, both exponents are positive. To simplify scientific notation, we can combine both of these together. The numbers in front, which are 2 and 3 in this case, we can multiply those. 2 times 3 would be 6, times 10 to the third and 10 to the second are two exponent numbers. They have the same base, which is 10, so 10 would stay the same. And the exponents, like we did in previous sections, we can add. 3 plus 2 would be 5th. So combining the two numbers into one single number using scientific notation, the answer would be 6 times 10 to the 5th power. And last question for the section. 8 times 10 to the negative 5th power times a second number, 7 times 10 to the negative 3rd power. And again, each of these numbers are in scientific notation, where you have a number less than 10 times 10 to some exponent. To combine two scientific notation numbers, we can multiply the numbers 8 times 7, which would be 56, and times 10. The exponents we can add negative 5 plus a negative 3, which would be negative 8. To simplify this one step further, again, scientific notation, the first number has to be less than 10. In this case, 56 is bigger than 10. So what we can do for scientific notation is if we have 56, the decimal point would be on the right of 56. We can move the decimal one spot to the left to make the new number 5.6. 56 again is bigger than 10, but by moving the decimal once to the left, we'll have 5.6, which is less than 10. Times 10 would stay the same. In scientific notation, when you move the decimal to the left one time, we'll take the exponent and we'll add 1 to that. So negative 8 plus 1 would be negative 7. So if you move the decimal to the left, you'll add that number. If in other questions you move it to the right, you'll be subtracting that number. Our final answer would be 5.6 times 10 to the negative 7th. Title of the first section, find the degree of a monomial. Definition for the section. The degree is the highest exponent or sum of the exponents of the variables. So for these questions, the degree will either be the highest exponent, or if we have more than one variable, we can take the sum or add the exponents together. First question, x to the fifth power. The degree again is the highest exponent, or if we have a single exponent, the degree would be 5. Second question, a to the third power and b to the fourth power. When you have two different variables side by side, we can take the sum or add the exponents together. 3 plus 4, so the degree would be 7. Third question, 2x. Right now there's no exponents listed in this question. If you remember from previous chapters though, the x, if it does not have a variable, we can add a 1 for the exponent. So 2x is the same as 2x to the first, so the exponent would be to the power of 1. And last question for the section, b5. For the degree of 5, since there's no variables, if we wanted to, we could add a variable. X to the 0 power would represent that there's no x's there, so the degree would be 0. So if you have a single number like 5, the degree will always be 0. For the first table, we can take the degree of a polynomial or monomial and find the name of that polynomial. If we have a degree of 0, which again means we have a single number that is a constant. If we have a degree of 1, the name would be linear. Degree of 2, quadratic. Degree of 3, cubic. And a degree of 4 would be fourth degree. Anything above 4 would be the number and degree. For example, 5 would be fifth degree. The second table, we can also classify by the number of terms. If you have a single term, that's a monomial. If you have 2 terms, a binomial. 3 terms is a trinomial. And 4 terms is a polynomial. Anything above 4 is going to be a polynomial. For example, if we have 5 terms is also a polynomial. Title of the next section is Name Expressions by Degree and number of terms. In this section, we'll use the previous two tables and name each expression by its degree and also by the number of terms. First question, 5x squared minus 2x plus 3. Looking at the first table, classifying this expression by the degree, when we have a single variable with different terms separated by a plus or minus sign, we want to find the highest exponent for the degree. The highest exponent is 2, and looking at the degree table for 2, this would be a quadratic expression. Also classifying by the number of terms, each term is also separated by a plus or minus sign. So looking at this expression, we have 3 terms, and looking at the table, if we have 3 terms, it is a trinomial. So this expression, when classified, would be a quadratic trinomial. Second question, x to the third power or x cubed. When you have a single variable, the highest exponent would be the degree total. If the degree is 3, looking back at the table, degree 3 would be a cubic expression. Classifying by number of terms, we have a single term, x to the third power. If we have one term, that would be a monomial. So x to the third power is a cubic monomial. And last question for the section, 2x minus 5. Again, looking for the degree, the highest exponent on the variable. We have one variable x with no exponent shown, but again, we can always add a 1 if there's no exponent. X to the first would be a degree of 1, and looking at the degree table, degree of 1 would be linear. And for the number of terms, each term again is separated by either a plus or minus sign. So in this expression, we have 2 terms. 2 terms would be a binomial. So 2x minus 5, when classified, is a linear binomial. Title of the last section today is Write Each in Standard Form. In this section, we'll take each expression and write the expression in standard form. The definition for the section, or definition of standard form, is order highest exponents to lowest exponents. In this section, we'll take each expression and order it from the highest exponents to the lowest exponents. First question is 4x minus 3x squared. To write in standard form again, we'll have the highest exponent. Looking at this expression, the highest exponent is 2, so the term minus 3x squared would be the first term since it has the highest exponent. And the next term, or the lowest exponent, 4x, since it's a positive 4x, we can put plus 4x. So in standard form, from highest to lowest exponents, negative 3x squared plus 4x. Second question and last question for the section. Y minus 7y to the third power plus 15y to the eighth power. Again, ordering from highest to lowest using the exponents. The highest exponent would be 8, so the term 15y to the eighth would be the first term for standard form. The next highest exponent would be 3, so the term minus 7y to the third power would be our second term. And our last exponent, which would be a 1 or a single y, since it's positive, we can put plus y. So our final answer would be 15y to the eighth minus 7y to the third power plus y. Title of the first section today is Adding Polynomials. First question, 3y to the second power plus 2, and underneath we'll have a plus sign, and we'll have 4y to the second power plus 4. And then we can draw a line under each of these for the addition. Adding polynomials, this is a vertical addition. We're going to add straight down. If we have 3y squared plus 4y squared, 3 plus 4 would be 7. And when you add similar variables or like variables, y squared would stay the same. So 3y squared plus 4y squared is 7y squared. And last part, 2 plus 4 would be 6. So our final answer is 7y squared plus 6. Second question. 5x to the third power plus 4x minus 3. And again, underneath we'll have an addition sign, and we'll add to that 2x to the third power minus 2x plus 2. Again, for a vertical addition, we can add straight down for all the like terms. 5x to the third power plus 2x to the third power would be 7x to the third power. 4x plus a negative 2x, or 4x minus 2x, would be positive 2x. And negative 3 plus 2 would be negative 1. So our final answer is 7x to the third power plus 2x minus 1. And last question for the section. In parentheses, 8a to the second power plus 1, close parentheses, plus a second set of parentheses, 12a squared plus 6a plus 4. In this section, instead of vertical addition where we can add straight down, this is called horizontal addition, where it's all written in a single line. To add these together, we can add the like terms. Like terms, again, have the same variable and same exponent. So if we have 8a squared, we can add to that 12a squared. 8a squared plus 12a squared would be 20a squared. The next variable that we have, we don't have any single a's in the first parentheses, but we do have a 6a in the second parentheses. Since there's no other a's, the 6a would stay the same. And the last numbers that we can add are the constants or single numbers. 1 plus 4 would be 5. The answers we want written in standard form, which if you remember are highest exponents to lowest exponents. So our final answer would be 20a squared plus 6a plus 5. Title of the last section today is Subtracting Polynomials. First question, 5x plus 4, and underneath we'll have a minus sign, and inside parentheses 3x plus 1. Just like before, we can take these two polynomials and subtract vertically. First term, 5x minus 3x, would be 2x. And the second term, keep in mind we're subtracting, 4 minus 1, which would be 3. So our final answer, 2x plus 3. Second question, 6x plus 2, and underneath we have a minus sign, and inside parentheses 3x minus 3. Again, subtracting vertically, 6x minus 3x would be 3x, and keep in mind we're always subtracting the numbers, so we'll have 2 minus a negative 3. If you remember from previous sections, a minus, this would actually change to adding 3. So 2 minus a negative 3 is the same as 2 plus 3, which would be 5. So our final answer, 3x plus 5. Next question, 7a squared plus 4a minus 8. And underneath minus sign, and inside parentheses 3a squared minus 2a plus 10. Again, since this is subtraction, we'll subtract vertically straight down each of the numbers with like terms. 7a squared minus 3a squared would be 4a squared. When you subtract, the exponents would stay the same. 4a minus a negative 2a. When we subtract a negative again, minus a minus, this will actually be adding. So we'll have 4a plus 2a, which would be 6a. And last term, negative 8 minus 10. Negative 8 minus 10. Both have the same signs, so we can add those, and we'll have minus 18. So our final answer, 4a squared plus 6a minus 18. And last question for the section. In parentheses, 17 n to the 4th power plus 2 n to the 3rd power, close parentheses, minus, inside a second parentheses, 10 n to the 4th power plus n to the 3rd power. Like before, when we have two parentheses side by side, we can still subtract, and this would be the horizontal subtraction. We'll subtract the common terms from each parentheses. So we have 17 n to the 4th minus the next into the fourth, which is 10 into the fourth. So 17 into the fourth minus 10 into the fourth would be 7 into the fourth. And the other like terms, n to the third power. We have 2 n to the third power, and keep in mind we're subtracting n to the third. So 2n to the third minus 1n to the third would be 1n to the third, or n to the third power. So our final answer, 7n to the fourth plus n to the third. Title of the first section is Multiplying using Distributive property. In this section, we'll simplify by multiplying using distributive property. First question is 2 and inside parentheses x plus 5. Distributive property, we can take the number outside the parentheses and multiply it by each number and each term inside the parentheses. So the first multiplication, 2 times x, would be 2x, and 2 times a positive 5 would be positive or plus 10. So our final answer, 2x plus 10. Second question, x and inside parentheses x minus 3. Multiplying again the number or term outside by each number and each term inside the parentheses. X times x. If you remember from previous sections, we can put exponents on these. And when you multiply, we'll be adding the exponents. So x times x would be x squared. And x times a negative 3 would be minus 3x. So our final answer, x squared minus 3x. And last question for the section, 3y. And inside parentheses, y plus 2. Again, multiplying the term outside by each term inside the parentheses. 3y times y would be 3y squared. And 3y times a positive 2 would be positive 6y. So our final answer, 3y squared plus 6y. Title of the last section today is More Multiplying using Distributive property. In this section, we'll continue to use distributive